When we solve quadratic functions, we are looking for the x-intercepts of the function. X-intercepts are also called zeros, solutions, and roots. One method to solve these functions is called factoring, and we've already covered that. First, you must take your equation, make sure your equation is quadratic. Second, it must be set equal to 0. Third, we have to factor. Lastly, we set each factor equal to 0 and solve for x. Okay. So, first example. I'm going to take this and I'm going to multiply A times C. And I need two numbers, and when added together, give me -6. Multiply together, give me -16. I'm going to say -1, 16. No. -2, +8. No, but that's +6. So let's try +2, -8. And those are my answers. So I'm going to go ahead, take this equation. I'm going to split apart the middle term and set it equal to 0. Now I'm going to factor out from the first section. Now I'm going to factor out in the second section, noticing that on the inside of my parentheses it's exactly the same. Because it is, I can combine like terms. Now that I have this, I should automatically know that my answers are going to be the opposite of the number that's in the parentheses with x divided by the coefficient of that x. So I know this is going to be +8, -2. But just to make sure we understand this, I'm going to take this equation and I'm going to do it the long way. So I'm going to divide both sides by x minus 8. Of course, 0 divided by anything stays 0. These guys cancel out, and I'm with x plus 2. I'm going to move my 2. There's my first answer. And if I did the same exact process for the other one, I would get x minus 8 equals 0, add my 8, and end up with my second answer. I can verify this in my Desmos calculator by plugging in my original equation and the factors if I so choose. So this is x squared minus 6x minus 16. And if I look at my graph, zoom out a little bit, I see here -2, +8. Same exact thing I got before. But let me verify even more. X minus 8 goes exactly through my x-intercept. X plus 2 exactly through my other x-intercept. And even if I multiplied them out together, I get exactly the same graph. So if you notice, the purple one sits on top of the red graph. So those answers are correct. Example number 2. First thing, I see that this has stuff all over the place. So I need to get this 6 to the other side. So that way my equation is equal to 0. Now I can go ahead and factor. I'm going to multiply A times C, add them together to equal 5. I don't know what numbers I can use, so I'll just start at the beginning. -1, positive 36. No. -2, positive 18. No. -3, positive 12. No. -4, positive 9. Yes. So now I'm going to go ahead and take my middle term and split it apart. Now I'm going to go ahead and factor from the first set. And I'm going to go ahead and factor from the second set. Couple of errors there. All right, just making sure we verify our math. I see that the inside of my parentheses are exactly the same, so I can combine like terms. And I have my factored equation. I know it's going to be opposite divided by coefficient. Again, opposite divided by coefficient. These should be my two answers. All right, so let's go ahead and verify. I'm going to go ahead and clear these out. And I'm going to plug in my next equation. 6x squared plus 5x minus 6. Okay? Now I'm going to go ahead and plug in my first factor. 2x plus 3. Noticing that it touches exactly at my x-intercept, so that's the correct answer. Let's look at the next one. 3x minus 2. And it touches exactly at the x-intercept. And even if I decided that I wanted to go ahead and plug both of these in and have them multiplying together just like I saw whenever I factored, I should get the exact same graph. Notice when I turn off the green graph, the black graph shows, and the green lays exactly on top of it. That means that is my exact answer. Okay, next part. A second method to solve these functions is called the quadratic formula. In order to use the formula, your quadratic equation must be written in standard form or ax squared plus bx plus c. So, whenever I do this, remember, all I'm doing is just plugging in the numbers. I can do this by hand, and I can also do this using my calculator. If I do it by hand, I'll get an exact answer with a radical sometimes. If I do it on the calculator, it's always going to give me a decimal. Okay. So first thing, I'm going to write out my equation. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So first thing is I'm going to go through and I'm going to identify who is who. This guy is a. This guy is b, remembering to include the negative. And this guy is C, also including the negative. Let's go ahead and plug those in. Noticing that if I have an extra negative there in front, I put the number in parentheses so I do not confuse myself. All right, so I got all my numbers plugged in. Let me just color code them so we can know where they came from. Okay, I'm going to continue solving this by hand. X equals negative negative 3 plus or minus square root of negative 3 squared. Negative 3 times negative 3 is 9 minus 4 times 2, which is 8, times negative 5, which will give me positive 40. All divided by 2 times 2, which is 4. Let me go ahead and simplify what's on the inside of that radical. Now I can go ahead and I can simplify the radical. What's the square root of 49? Well, it's 7. So if I get something that's simple like this, I just go ahead and break it apart. One is going to be adding, one is going to be subtracting. So I should have x-intercepts located at positive 2.5, negative 1. So I'm going to verify that by plugging it in. Let's go back to Desmos. I'm going to turn off these other graphs, just in case I want to come back to those later, and I'm going to go ahead and plug in my new equation. 2x squared minus 3x minus 5. Let's look to see where the x-intercepts are. Negative 1, positive 2.5, exactly where I predicted. Those are where my answers are. Let's go ahead and do the next problem. Same thing again. It looks like I have stuff all over the place. I need this to be equal to 0. So I'm going to move that 7x. And I'm also going to move that 4. All right, now I can go ahead and start plugging things in. So I'm going to go ahead and first write out my equation. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I'm going to identify where my different pieces are. A, B, including the negative, and of course, C, also including the negative. So x equals negative 7 plus or minus negative 7 squared minus 4 times A times C, all divided by 2 times A. Again, here was my C, here was my A, and my B. Let's start simplifying. So double negatives, make that positive. 2 times 9, that's 18. Negative 7 times negative 7, that's 49. 4 times 9 times 4, no idea. Let's plug it in just to make sure. Negative 4 times positive 9 times negative 4. Positive 144. Okay, let's go ahead and simplify what's on the inside of that radical. 7 plus or minus square root of 193 over 18. Now, this one, I know 193 is not an exact square root. So I'm still going to break it apart, except I'm going to write an approximate number. Let me put these in the calculator. So 7 plus square root of 193. And I want that entire thing to be divided by 18. And let me go ahead and plug in the other one. 7 minus square root 193, all divided by 18. Okay, so let's turn this guy off. And let's go ahead and plug in our original equation to make sure we did this right. 9x squared minus 7x minus 4. And look at that. It looks like our x-intercepts match exactly what we got whenever we plugged this in. It just truncated our number a little bit. So I know my math is correct, and my answers are approximately 1.16, negative 0.38. All right, next part, solving using square roots. So sometimes we can have that difference of perfect squares, or we don't have a b value, or we have all kind of other interesting things. So a second method used for solving quadratic equations is taking the square root. In order to use this formula, your quadratic equation must not have a middle term or a b in ax squared plus bx plus c. So it needs to look like this. The golden rule of square roots. Taking the square root of a negative will result in imaginary solutions. Why is that? Well, there's no number that whenever you multiply it times itself, that it'll give you a negative number. So this is no solution. Our steps are always going to be the same. Isolate x squared, take the square root of both sides, solve for x, and include plus and minus in the answer. This tells us that we have two potential solutions. All right, so let's do this one. First thing, I want to isolate my x squared. Let's move this 144. I know the opposite of squaring is to take the square root. What's the square root of 144? Well, 12 times 12 is 144, but negative 12 times negative 12 is also positive 144. So I have two answers. X equals plus or minus 12. So I should have two x-intercepts, one at negative 12, one at positive 12. Let's go ahead and graph this and make sure. I'll turn this one off. X squared minus 144. Let's zoom out. Okay, and it looks like positive 12, negative 12. We were correct. So those are my answers. Number 2. So first thing I want to do is I want to get that x squared by itself. Let's move this 5 over. I see that 1 over 5 in front of my x squared is a coefficient, so I'm going to multiply everybody times 5 to get rid of it. I could have also multiplied by the reciprocal, 5 over 1. All right, so now I've got my x squared isolated. I could take the square root of both sides. The square root of 25. Well, I know 5 times 5 is 25, but negative 5 times negative 5 is also equal to 25. So I have two answers again, positive and negative 5. Let's plug this in to make sure that we got the correct answer. 1 over 5 x minus 5. Excuse me, x squared minus 5. Okay, let's look at these. Positive 5, negative 5. Good job. We got the right answer. This one's correct. All right, example 3. What are the solutions to this equation? Well, first of all, I see here that there's a lot more going on, but I'm going to still follow the same process. I'm going to get this squared part all by itself, and let's see if we can do the exact same method. This might look a little different, but it's exactly the same. I see it's multiplied by 4. I'm going to divide everybody by 4. Let's find out what 324 over 4 is. It's 81. All right. Now I can go ahead, because I have everything is inside of the square, I'm going to take the square root of both sides. I end up with x minus 5 equals 9 times 9 is 81. Negative 9 times negative 9 is also positive 81, plus or minus 9. Now I'm going to go ahead and I'm going to continue to try and get my x by itself. First thing I'm going to do is I'm going to add add my 5. So this becomes x equals 5 plus or minus 9. Because it has a plus and a minus, that means that I'm going to have two separate equations. I'm going to break this apart. X equals 5 plus 9. X equals 5 minus 9. So I should have two x-intercepts here, one at x equals negative 4 and one at positive 14. So let's go ahead and graph this and see where they land. Remembering that I have to type in my equation exactly as I saw it, but since this one wasn't equal to 0, I'm going to move that 324 over. 4 parentheses x minus 5 squared minus 324. Let's look to see where our answers are. Positive 14, negative 4. Exactly where we predicted. We got that one right as well. Okay. A cliff diver dives off a cliff 70 feet above the water. This can be modeled by this function. How long is the diver in the air? So, let's draw this out. I have a cliff. I have somebody standing on it, and they're going to dive until they get to the very bottom. Right here, they're at 70 feet. Here, because they're at the bottom, they're at 0 feet. So that means h equals 0. So 0 equals negative 16t squared plus 70. I'm going to go ahead and isolate my variable. Exciting move. And divide by my coefficient. Great divide. And I get t squared equals 70 over 16. Now, I'm going to go ahead and take the square root of both sides. So t is equal to plus or minus square root of 70 over 16. Let me plug that in my calculator, remembering that I'm going to get two answers, one positive, one negative. Square root of 70 over 16. 2.09. So I have positive 2.09 or negative 2.09. Well, let me refer back to the question. How long is the diver in the air? That's a measurement of time. I have never, ever seen a circumstance where you can measure time in negatives. We can't travel back in time. So only one of these answers makes sense, the positive one. T equals 2.09. But let's verify this by plugging in this equation. Negative 16 x squared plus 70. And let's look at the x-intercepts. Negative 2.09, positive 2.09. So we also got that one correct.